Okay, so I've turned on the toothbrush and it dances its way merrily around because it's vibrating a lot. You'll see it turning around as we go along. But basically I've turned it on and the camera's running, and I haven't set any of the settings correctly yet. That's what we're going to do now, but you can see already it's showing something coming from the toothbrush. So, okay, so what have we got on the screen as far as settings go? We've got a window at the bottom showing us all the frequency range. So if you see the scale on the right there is from 0 to 24 kilohertz at the moment. We're actually able to expand that with finger gestures and change that to however we want, move it about so that we can see whichever range of the frequency range we want. I'll just leave it small at the moment. Now if we double click on that, we can cycle through a picture that shows the complete frequency range like this, just the color map. And that's really good because right now we're just getting a picture of all the sounds that are coming, that the camera is seeing basically. They're coming from our test object. You can't see the beam picture at the moment, but you can see the whole frequency range of sounds, and you've got a sliding time scale from 0 to -18 because I've got it set at the moment, which I'll change actually. This is a clock symbol there, the second one. If I change that, it's going to save the last 10, 30 or 60 seconds. I'll go to 10 because otherwise it takes a bit longer to save the data away and you'll get impatient with me. So I'll set that to 10 seconds, and now it shows from 0 to -10 in time of what's just happened. So this is actually happening now. So if I clap my hands in front of it better, you'll see that it's picking up my hand clapping, and they happen, and the toothbrush fell off. Okay, it's going to be a comedy video, I can see that. So now as I turned it off and on, you can see that as well, that the sound completely changes. I'll do that again. See, without sound and me talking behind it, it's picking up a little bit, but not very much. I turn it on and it picks up a lot. Now if I take it away and have it the same distance away from the SOUNDCAM but not in front of it, you can also see that a lot of the frequencies disappear. So it's actually really sensitive only to what's in front of it, which is a nice advantage of the SOUNDCAM. It means you can use it in noisy environments and it won't get too disturbed by other machines around or other things happening around or people talking even or whatever. Like I'm going to talk the whole time and it'll still show a nice clean beam picture. So, okay, important now that we've got the frequencies there is to say, okay, what's the ones that might be bothering us, which frequencies are disturbing levels and which ones are okay. Now we're looking at the moment right up from 0 to 24 kilohertz, which is the whole audible range. At the top there you can see a band which is going from about 17 to 20 kilohertz roughly, quite a high band. The lighter the colour, the more yellow, the louder it is. There's one here in the middle, and there's several down the bottom here as well. So we could start at the top. So if we press, so basically here are the buttons that you have to set to get a good beam picture. There's 3 of them. There's one at the top which has got an M, it looks like a distance. It's that one now. Press that one and you can see there's a distance slider comes out, set to a meter at the moment, which obviously we're only about that far away, which is about, I don't know, 20 something centimeters. So I'll slide it down to that sort of range, about 20 something. Doesn't have to be pinpoint accurate on distance, but the sharper you'll get it, the more sharp you'll get the picture, but it needs to be a long way out before it makes much difference. So distance set roughly right, that's the first thing you can do. How far away is the measurement object, because it's calculating the sound that is at that plane that's a certain distance away. So it's not calculating the sound from everywhere. It can't show that all at the screen on the one time. It's counting only from this plane, which is the distance you've just defined. So I've set the distance. Now the second one we're going to come to third actually. I'd have preferred them in a different order, but I'm only the distributor, so I'm not allowed to say things like that. The third one is the one I want to cover next, which is the frequency range. So we can set the frequency to cover this band. So if I move the top slider up above that high frequency band, which is actually out of the hearing range of me and a lot of other people on the planet, you can narrow it down to that top one if you like. Now the beam picture is being calculated for that frequency band, which is 177 hertz, 17 kilohertz, or nearly 18 up to 20 kilohertz in this case. So if you want to see the effect of that, I'll double click and you can see the picture in small. I'll double click again, you can see the picture a bit bigger. I'll double click again and you can see just the picture, but it's still doing that frequency range. Now if you look carefully, you might see the little colour spot very accurately located just below. If there's fucking toothbrush, doesn't. I didn't say that. Cut. Right, so if you look carefully, you'll see a little spot just below the point where the rotating part of the toothbrush and the oscillating part meet and interface, and it's up near the top of the toothbrush. I'll point my finger near it there somewhere, and we can make that more obvious. This is now where the third button comes in, the dynamic range, where it says max min. So I'll press that one, and at the moment it's on a very low dynamic range, which might be good for low frequencies because there's a lot more energy, but for high frequencies like this it's good to slide it up a bit so you can really clearly see the sound source. Now you should be able to see it quite well. If you put it up too far, then you're showing everything in the world and all the reflections and everything else, and it gets a bit hard to see. So slide that down until it's pinpointing the frequency you've selected, and voila, you have found that frequency band on that machine. So if you want to make that machine quiet at that particular annoying really high frequency that drives cats and children mad maybe, but adults don't even hear it, then that's the place to do your work. I double click again, I'm back to the frequency graph. I can go now pressing that frequency graphy sort of icon. I can go down for one of these. I'll use my fingers to optimize the graph a little. I'll go for a band down here and see where that's coming from. So I've got to move both of the sliders around that band and see where we get to. So now I'm around 7 to 9 kilohertz. So if I double click again, I'll see the toothbrush again, and keep double clicking through. I can leave it on this one if you like, then you see both pictures at the same time. And if I go down on the dynamic range again, because it's a lower frequency, they always have more energy, you can see again we're looking in a similar area to before actually. Very similar. It might be slightly lower down than the actual rotating part, but very similar frequency area. So even that area, which is an annoying area, is also coming from that same location on your machine. Could be any kind of machine, of course. So I'm going to go down a bit lower again with frequency, and we can keep doing this until we've picked out the next band down here. You can see, if I double click that so you can see a bit better, I've just zoomed in on this band down here. And of course I haven't saved any data now, all I've done is had a look at it on the screen, so I'll do that next probably. That's a good idea. So I've selected the next band down, we're still up in the top area. Maybe I'll jump down to something more interesting. Okay. Right, so I'm going to select a lower frequency band just to vary a bit where there's quite a lot happening, quite down here somewhere. You see there's still quite a lot of activity over a broad range. And now we're starting to see there is something going on at the top, but mostly it's coming from down below where the motory gearbox sort of area is. So what we can do is at any time we can take a screenshot. So first thing we could do is to stop the actual online analysis. If we press the stop button here, which before was the green start button, but now it's running, it's a stop button, top left button, press that, everything's stopped even though my machine's still going. Turn it off because it's annoying me and it might fall over again. And you can scroll through with your finger if you want. Along the time you can of course expand to a particular event with your fingers and scroll through, or you can use the buttons here to go one frame at a time backwards or forwards through the measurement. So if there was a transient that happened, if this is a machine that goes bang bang bang, then you might want to do that to locate the bang bangs. You'll see them as vertical incidents like when I clapped earlier on the screen, and you'll be able to find exactly where they're coming from. So we can't do that. Right, so now the measurement isn't running anymore. we can scroll through it with the finger. We can take screenshots by pressing this button here. It's the second one down on the left that's got a camera with a flash icon. It says screenshot saved on the top there. I don't know if you can read that. We can do that as many times as we like to different sections and save lots of screenshots. Or we can do the second button down on this side that looks like a clapperboard and press that one, and it gives us a chance to export a video. I'll come to that in a second, because the other thing that we can do, of course, is to save the raw data. So there's disk icons on the left here, and the bottom one, the lower one I should say, gives you a chance to save it. Now it date and time stamps it and gives it our prefix, which if you click on it you can alter all that and delete and whatever, make a unique name. But if you want to accept that, you can just tick it and it'll save that in the default place that we've defined, saving the data to a file like it says. So now we've saved the raw data, but that's not in a format that any of your colleagues can read if they haven't got this software. Although you can put the software on a PC, it's a free license, so you can install it anywhere you want and set. So if people have got the software, they can do it. But otherwise, normally what you do is press this clapperboard button, go into the export dialog. Whoops, if I press it properly, my fingers don't always work. And I'll just get rid of those markers because I did those while I was trying it out. You can now, if you press the top button, it'll set a marker of the start. Go somewhere else, press the bottom button, set a marker for the end. And if that wasn't right, get rid of the markers and do it again. This is the next button. And the fourth button down will now go into an export dialog for that marked area. So it'll go in the default directory, you can change that. It'll export audio and video. You can change that to audio only or video only if you want to. You can change the speed it'll export it to real time, which was 25 frames a second of normal video, or you can do a 50 frames per second real time, or you can slow it down or speed it up as well by 1/2 and 1/4. No, slow it down by 1/2 and 1/4, you can't speed it up. But sometimes you do want to slow down these things that have happened. So quality, leave it on high, it doesn't take long on high anyway. It's my advice, but you can reduce the quality if you're impatient. You go on this one here and you've got two choices of video formats for Vorbis OGG and Opus Webm. And Opus Webm works in most browsers where people can open it directly without a video software, so it's not a bad thing, but I think OGG is pretty universally readable as well. So when you've set all that up how you want, there's a sound level button here. So if you press that, you can increase the sound level on the video. In this case, it will go all the way up, which is not what I was hoping would happen. Usually there's a sign somewhere that says clip, and you know that if you choose that level of amplification of the sound, you'll get a distorted video, so you go one down from where it says clip. But you'll have to believe me, you'll see it yourself when you do something else. So we choose the highest level before it says clip, which I can't really do in this case, and then you can tick and you'll get a video exported again to the hard disk in your default directory, but in a readable format for everybody. So it doesn't take long, and all you've got so when it's finished, which it will say so in a minute, I think. It says 100%, but normally, come on baby, it'll do it. When it's finished in a second, there we go, it's finished, and the dialog comes back again. You could put your stick in and transfer it into the slot. So basically, to get out of this, don't press the tick button. If you press the tick, it'll export the video again, because it thinks you're just saying I want to do this again. You press the X to get out. As soon as it did it. So press the X and get out. Now we're in still reviewing that data that we saved. It's still in the buffer. Now if we press the play button, the green one again, we've gone live again. So you'll see that will disappear because the toothbrush now lying down and it's not making any noise. If I flick like this, you'll see what I mean about these transients I was mentioning, that you know, a transient incident, if I stop the video again, I can scan through and look at a transient and see exactly what was happening. You'll see me flicking my fingers, it's astonishing. Bam, see, and you can see the sounds coming from my fingers. That's really surprising. But this could be a machine where you don't know where the sound's coming from, obviously. So you can slow it right down, you can zoom right in, you can step bit by bit through it and see what the actual maximum level was as well of that flicking incident. I managed to hit 52 dBs. I was really flicking hard. So 52.2 dBs I managed to flick at, or snip my fingers at, to say more accurately. If I want to make a screenshot of that again, I press this button I can send it to the world, they'll be amazed. If I change, what you can do after you've recorded is change the dynamic range, so I can make it look like my hand's on fire, or I can show exactly where my fingers were that did the snipping and make it really accurate by putting it right down. But it's sometimes hard for people to see what you're showing them if you make it too precise. So you can have it really precise down to a pixel or two, or you can overwhelm the picture and then you hide everything as well. So it's always a bit of a compromise, but you'll work that out. What I haven't shown you is some interesting stuff like the scaling options. So we had it, if I set it off again onto normal running. Now notice I didn't save that flicking video, so it's gone forever now. It's a bit sad, I know, but we'll get over it. The flicking video wasn't saved by me pressing either the raw data or by exporting it, or by both. I just didn't do any of those, so it was in a temporary buffer. The last 10 seconds are always in a temporary buffer when I press stop, or 30 or 60 if you set it for longer. And unless you save them to the disk, you've lost them, so beware. I've done that myself too many times. So scaling, we'll go on to the scaling now. So if we turn on our old faithful toothbrush again, if we press the scaling button here, the dynamic scaling, you can see that it's set to auto, the first blue button there, with a 1 dB dynamic. And we've been through the dynamic, that just makes it bigger and smaller, but auto is auto scaling it all the time. So if you turn it off, it hasn't really got a sound source to find except me talking, and it goes right down to 1 dB or something. It goes really low and looks at all the low level stuff if I don't say anything. So you can see it's auto scaling, and then it's picking up reflections of my voice off the wall and all sorts of things. So if you're seeing all sorts of crazy things, it's not malfunctioning, it's just gone down to such a low level that it's actually picking up reflections from any noises around, you know. It's still working accurately, but you're not pointing at anything, and you're not, but the frequency range may be set to what you're pointing it at. So you've got to set it up, and then it will work for you basically. And if you look at what it's telling you, now I'm up to 46 dBs, which is in this quiet office, it's a significant level. And while I'm talking, it doesn't care because I'm pointing it that way, and I'm looking at a particular frequency band where my voice maybe isn't coming in so much, 5 kilohertz. 3 to 5, I will have a bit of voice in there actually, even with my droning, but it's not affected because it's looking the other way basically. So it's really good for sound sources that are close to each other. So I was going to show you something and I completely forgot what it was. Oh yeah, the scaling. So the different sorts of scaling. Auto scaling is automatically auto scaling the whole time, and it's showing you below that auto scaled level the dynamic of 0.9 dB in this case. If I press the upper button, the blue button here, I get to smart scaling. Now smart scaling is ignoring constant noises. Okay, some are more constant than others. This is sort of a rat-a-tat-a-tee one. It probably would ignore the higher frequencies better, but if you had, say, an air conditioning noise, then you know, it would, if it was a fan going all the time, it would ignore that constant noise and average that away, and only look for transients like that come and go over a particular amount of time. And you can actually set the crest factor on that as well to say how long should the crest factor is a measure of how big is the transient compared to the average. So the different setting of that level will show more aggressive sounds or less aggressive sounds depending on where you put that. So the smart is really good if you're looking for a bam 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 thing and there's lots of constant noises around and you just want to pick out the transient noise. But most of the time you use it on auto scale, or you can turn it off and you can actually then it won't auto scale down. It's stuck on the last one it was on, which was 36 dBs in this case, and until it finds something in that range it won't show anything at all. My talking or the reflections of me sometimes get into that range, as you can see. If I turn the toothbrush on now though, it overwhelms the picture rather, because its level was around 40, it's like around 10 dB more. So if I put that back on auto scale, you can now see it's gone back to showing the level of that item there quite well. So that's scaling for you, and you need to just point it at things and play around and see what that does. But it's one of the things to think about, that you need to think about to get the best results out of this. So I'll turn that off and